Good day, good day everyone, especially to Sir Miggy, our instructor in the IT. Today I will be discussing about database normalization process. Description of the database normalization basics. Description of normalization. Normalization is the process of organizing data in a database. This includes creating tables and establishing relationships between those tables according to rules designed both to protect the data and to make the database more flexible by eliminating redundancy and inconsistent dependency. Redundant database disk space and creates maintenance problems. If data that exists be changed, the data must be changed in exactly the same way in all locations. A customer address change is much easier to implement if that data is stored only in the customer's table and nowhere else in the database. What is an inconsistent dependency? While it is intuitive for a user to look in the customer's table for the address of a particular customer, it may not make sense to look there for the salary of the employee who calls on that customer. The employee's salary is related to or dependent on the employee, and those should be moved to employee's table. Inconsistent dependency can make data difficult to find, difficult to access because the path to find that data may be missing or broken. There are a few rules for database normalization. Each rule is called a normal form. If the first rule is observed, the database is said to be in first normal form. If the first three rules are observed, the database is considered to be in third normal form. All through other levels of normalization are possible. Third normal form is considered the highest level necessary for most application. As with many formal rules and specifications, real-world scenarios do not always allow for perfect compliance. In general, normalization requires additional tables, and some customers find this cumbersome. If you decide to violate one of the first three rules of normalizations, make sure that your application anticipates any problems that could occur, such as redundant data and inconsistent dependency. The following description include examples. First normal form: eliminate repeating groups in individual tables. Create a separate table for each set of related data. Identify each sets of related data with a primary key. Do not use multiple fields in a single table to store similar data. For example, to track on inventory item that may come from two possible sources. As inventory record may contain field for vendor code 1 and vendor code 2. What happens when you add a third vendor? Adding a adding a field is not the answer. It requires problem table modifications and does not smoothly accommodate a dynamic number of vendors instead. Please all vendor information in a separate table called vendors, then link inventory to vendors with an item number key or vendors to inventory with a vendor code key. Second normal form. Create separate tables for sets of values that apply to multiple records. Relate relate these tables with a foreign key. Records should not depend on anything other than a table's primary key. A compound key if necessary. For example, considered a customer address in an accounting system. The address is needed by the customer's table but also by the others: shipping, invoice, account receivable, and collection tables. Instead of storing the customer address as a separate entry in each of these this table, store in one place, either in the customer's table or in a separate address table. Third normal form. Element field that do not depend on the key. Values in a record that are not part of that record's key do not belong in the table. In general, anything the contents of a group of fields may apply to more than a single record in table. Consider placing those fields in a separate table. For example, in an employee recruitment table, and candidates' university name and address may be included, but you need a complete list of universities for group mailings. If university information is stored in the candidates table, there is no way to list universities with no current candidates. Create a separate universities table and link it to the candidates table with a university code key. Exceptions. Adhering to the third normal form. While theoretically desirable is not always practical. If you have a customer's table and you want to eliminate all possible interfield dependencies, you must create separate table for cites, GIP codes, sales representatives, customers classes, and any other factor that may be duplicated in multiple record. In theory, normalization is worth forcing. However, many small tables may degrade performance or exceed open file and memory capacities. It may be more feasible to apply third normal form only to data that change frequently. If some dependent fields remain, design your application to require the user to verify all the related fields when any one is changed. The other normalization forms, fourth normal form, also called Boyne's Code Normal Form, BCNF, and fifth normal form to exist, but are rarely considered in practical design. This, disregarding these rules may result in less than perfect database design, but should not affect functionally. Normalizing an example table, these steps demonstrate the process of normalizing a fictitious student table. I have there a sample of a normalized table. Next is first normal form. Number repeating groups. Tables should have only two dimensions since one student has several classes. These classes should be listed in a separate table. Fields classes 1, class 2, and class 3 in the above records are indication of design trouble. Spreadsheets often use the third dimension, but tables should not. Another way to look at this problem is with a one-to-many relationship. Do not put the one side and the many side in the same table. Instead, create another table in first normal form by eliminating the repeating group. Class number as shown below. Third is second normal form. Eliminate redundant data. Note the multiple class number values for each student number value in the above table. Class number is not functionally dependent on student number. Primary key, so that relationship is not in second normal form. The following two tables demonstrate second form normal. Third normal form, eliminate database data not dependent on key. In the last example, EDV-ROM, the advisor's office number is the functionally dependent on the advisor attribute. The solution is to move that attribute from the students table to the faculty table as shown below. The advantage and disadvantage of both normalization and denormalization of a database are discussed, as well as data integrity versus performance issue that pertain to normalization. The highlights of this are include what normalization is, benefits of normalization, advance of the normalization techniques, guidelines of normalization, the three normal forms, database design. Normalizing database normalization is a process of reducing redundancies of data in a database. Normalization is a technique that is used when design and redesign. A database normalization is a process of or set of guidelines used to optimally design a database to reduce redundant data. The actual guidelines of normalization, called normal forms, will be discussed later in this hour. It was a difficult decision to decide whether to cover normalization in this book because of the complexity involved in understanding the rules of the normal forms this early on in your SQL journey. However, normalization is an important process that, if understood, will increase your understanding of SQL. We have attempted to simplify the process of normalizations as much as possible in this hour. At this point, don't be overly concerned with all the specifics of normalization. It is most important to understand the basic concept. The raw database, a database that is not normalized, may include data that is contained in one or more different tables for no apparent reason. This could be bad for security reasons. Disk space use speed or queries efficiency of the database updates, and maybe most important, data integrity. A database before normalization is one that has not been broken down logically into smaller, more manageable tables. Figure 4.1 illustrates a database used for this book before it was normalized. Logical database design. Any database should be designed with the end user in mind. Logical database design, also referred to as the logical model, is the process of arranging data into logical or organized groups of objects that can easily be maintained. The logical design of a database should reduce data repetition or go so far as to completely eliminate it. After all, why store the same data twice? Naming conventions used in a database should also be in standard and logical. What are the end users needs? The needs of the end user should be one of the top considerations when designing a database. Remember that the end user is the person who ultimately use the database. There should be easy for use through the user's front end tool. A client program that allows a user access a database. But this, along with optimal performance, cannot be achieved if the user's needs are not taken into considerations. Some user-related design considerations include the following. What data should be stored in the database? How will the user access the database? What privilege does the user require? How should the database group in the database? What data is the most commonly accessed? How is all data related in the database? What measure should be taken to ensure accurate data? Redundancy. Data should not be redundant, which means that the duplication of data should be kept to a minimum for several reasons. For example, it is unnecessary to store an employee's home address in more than one table. With duplicate data, unnecessary space is used. Confusion is always a threat when, for instance, an address for an employee in one table does not match the address of the address of the same employee in another table. Which table is correct? Do you have documentation to verify the employee's current address? As if data management were not difficult enough, redundancy of data could prove to be a disaster. The normal form. The next sections discuss the normal forms, an integral concept involved in the process of database normalizations. Normal form is a way of measuring the levels or depth to which a database has been normalized. A database level of normalization is determined by the normal form. The following are the three most common normal forms in the normalization process. The first normal form, the second normal form, the third normal form. Of the three normal forms, its subsequent normal form depends on normalization steps taken in the previous normal form. For example, to normalize a database using the second normal form, the database must first be in the first normal form. The first normal form, the subject of the first normal form is to divide the base data into logical units called tables. When each table has been designed, a primary key is assigned to most or all tables. Examine figure 4.2, which illustrates how the raw database shown in the previous figure has been developed using the first normal form. You can see that to achieve the first normal form, data had to be broken into logical units of related information. It's having a primary key and ensuring that there are no repeated groups in any of the tables. Instead of one large table, there are now smaller, more manageable tables. Employee TBL, customer TBL, and product TBL. The primary keys are normally the first columns listed in a table. In this case, EMP ID CUST ID, and PROD ID. The second normal form, the objective of the second normal form is to take data that is only partly dependent on the primary key and enter that data into another table. Figure 4.3 illustrates the second normal form. According to the figure, the second normal form is derived from the first normal form by further breaking two tables down into more specific units. Employee TBL split into two tables called Employee TBL and Employee Pay TBL. For personal employee information is dependent on the primary key, AMPID, so that information remained in the employee TBL. Last name, first name, middle name, address, city, state, GIP, phone, and figure. On the other hand, the information that is only partly dependent on one employee ID, its individual employee, is used to populate employee pay TBL ID position. Position, date, hire, pay rate, and date last raised. Notice that both tables contain the column employee ID. This is the primary key of each table and is used to match corresponding the data between the two tables. Customer TBL split into two tables called customer TBL and orders TBL. What took place is similar to the order information for a customer is dependent on its cost ID, but does not directly depend on the general customer information in the original table. The third normal form. The third normal form's objective is to remove data in a table that is not dependent on the primary key. Figure 4.4 illustrate the third normal form. Drawbacks of normalizations. Although most successful databases are normalized to some degree, there is one substantial drawback of a normalized database: reduced database performance. The acceptance of reduced performance requires the knowledge what when a query of transaction request is sent to the database. There are factors involved such as CPU use, memory use, and input-output I/O. To make a long story short, normalized database require much more CPU, memory, and input and output to process transactions, and database required than those the normalized database. A normalized database must locate the requested tables and then join the data from the tables to either get the requested information or to process the desired data. A more in-depth discussions concerning database performance occur in HAR 18, managing database users. Denormalizing a database, denormalization is the process of taking a normalized database and modifying table structures to allow controlled redundancy for increased database performance. Attempting to improve performance is the only reason to ever denormalize a database. A denormalized database is not the same as a database that has not been normalized. Denormalizing a database is the process of taking the level of normalization within the database down a notch or two. Remember, normalizations can actually slow performance with its frequently occurring table joint operations. Table joins are discussed during 13 hour. Joining tables in queries. The normalization may involve recombining separate table or creating duplicate data within tables to reduce the number of tables that need to be joined to retrieve the requested data, which result in less input and output and CPU time. There are costs to denormalization. However, data redundancy is increased in a denormalization database, which can improve performance but requires more extraneous effort to keep track or related data. Application coding renders more application because of the data has been spread across various tables and may be more difficult to locate. In additional, referential integrity is more of a chore. Related data has been divided among a number of tables. There is a happy medium in both normalization and denormalization, but both required a truth knowledge of the actual data and the specific business requirements of the pertinent company.